Hello viewers, welcome to Famous Julius Academy. In today's video, we are going to be dealing with introduction to differentiation. Just as we've seen in our last video, but in today's video, we are going to dive deeply into differentiation compared to the initial video. Today, we are going to see three techniques we can use in solving questions on differentiation. And the three techniques here are the product rule, we have the quotient rule, and we have the chain rule. But I might be discussing only the product rule for this video, and the next video I'll be discussing the quotient rule, and the previous one, the next one, I will be discussing the chain rule. So in that order. Take note of something. The reason why I'm going to do this is because I want you to have a deep understanding of the product rule. So while you watch this video, stay tuned to the end. You're going to get every details of the product rule that you need to know. Because students can see question, not that they don't know how to solve it, but they don't even know the technique to apply in order to resolve that question. And that becomes an issue. So the first thing is for you to look at the nature of the function and know the method that you are going to use to solve the question. And these are some of the things I'm going to be talking about in this video. So please stay tuned to the end of the video. Now, what is product rule? If you look at this word, you notice this the keyword here, the products. Products means multiplication, that is times, right? And we know product is multiplication. That means what we are going to be dealing with when we are talking about product rule must deal with multiplication. What is multiplying each other? We are going to see that now. In differentiation, what are we doing? We are actually differentiating what we call functions. We call them functions. We differentiate functions. Functions or relations are mathematical expressions that shows a relationship between two variables, the independent variable and the dependent variable. So relationship is what we call function. Function, I'm going to deal with a video on function and explain everything you need to understand about function in subsequent videos ahead. We are going to be differentiating functions in differentiation. And one of the functions I'm going to give you, I'm going to be more familiar with, is the quadratic function and the linear function. That does not mean that they are not other type of function in mathematics. They are. We have the trigonometric function, we have the anabolic function, we have the logarithmic function, we have the exponential functions. All these we shall be looking at in videos ahead. And now let's focus on the product rule. Now, if I have a function, this is the general way of writing a function is y is equal to function of x. What's the meaning of this statement? You might not understand, but I'm going to explain it. Y is equal to a function of x. It actually means that this y you are seeing has a relationship with a particular variable, and the variable is x. Y is having a relationship with a particular variable, and the variable is x. So, for example, I can write an expression like this: y is equal to 2x plus 3. What you are seeing here is still the same thing as what we have here. Mathematical expression. This y is a function of x. Why? If you look at the right hand side, you can see that the right hand side we have x there. What if I write something like this? Y is equal to 3p plus 4. What would be the nice expression for this? It would be y is a function of p. Are you getting it? That does not mean that it must only be of one variable. Let me assume I have something of this nature. Y is equal to 2x plus 3y, plus 3 w plus 4. You notice in this side we have x, we have w. I can say y is a function of x and a function of w. You must get this. This picture must be on your mind. So this is how we understand this function of a thing. Because what we are going to be differentiating here is function. The product we are going to deal with is functions. Okay, now if we want to use the product tool, what are the instances that will make us use the product tool? I've mentioned one. There must be product, which is multiplication. That's one of the things. What is multiplying each other? Two functions will be multiplying each other. Two functions will be multiplying each other. Let me assume I have y is equal to 2x plus 4 bracket x plus 3. What do you notice here? We have two functions here. Here we have y, we have 2x plus 4, we have x plus 3, and they are multiplying each other, right? So because they are multiplying, that tells me first tells you product can work. Now let me look at the function. This is a linear function and it's a function of x. This is a linear function, is also a function of x. So that means that both this and this are both function of x. If that condition applies, then product will be used. What is the first thing? Two functions must be multiplying each other. The first thing. Second thing is what? That the product of the two functions, the two functions, they must be functions of x. This is the function of x. This is the function of x. That's the first case that we can use product to. The second case is that when we have a product of two functions, one is a function of x and the other one might be a constant function. Let me assume I have y is equal to 2x plus 4 multiplied by 2. This guy is not having x, so we call it a constant function. When a constant function is multiplying another function, we can use product rule in that case. I'll be saying x. That does not mean that all the functions must be in respect to x. No. This might be p, it might be w, it might be any other thing. But the condition I'm saying is that if the independent variable here is x, the one here should also be x. If this is y, the one here will also be y. So that's what I mean. So the two conditions I'm trying to say is that the two functions that I'm applying to must be with respect to the same independent variable, or the two functions must be that one of them must have the independent variable and the other one is a constant function. In those two cases, we can solve them with product rule. And let's now see the product rule formula. So product rule tells us that if we have y is a multiple of two functions, u and v. On what condition did I tell you? I say y, u must be a function of x and v must be a function of x. So we say y is equal to u is a function of x and v is a function of x. Under this condition, what do? The derivative of y with respect to x is going to be dy over dx equal to v du over dx plus u dv over dx. And that is the product rule formula. This is the product rule formula. dy over dx is equal to v du over dx plus u dv over dx, where these two functions are both function of x. They might not be function of x, but one can be a function of x and the other one be a constant function. It will work out that way. But we are finding the derivative of both of them with respect to x. With respect to x. So that should be clarified. And let's now use this formula to resolve a particular question. Let's use this formula to resolve a particular question. Now let's say, which am I going to use here? Let's use this first one. Let's use this first question. Y is equal to 2x plus 4x plus 3. So if you use that here, what are we going to have? We have y is equal to 2x plus 4 multiplying x plus 3. So what are we going to have in this case? We are going to split both of them as u and v. So this one is u, the other is v. Therefore, we can say that u is equal to 2x plus 4, right? And what about v? V will now be x plus 3. Okay. I hope you're getting this. Now, we cannot find the derivative of u with respect to x. Also find the derivative of v with respect to x. Don't forget, we differentiate the independent variable, so the dependent variable with respect to the independent variable. If you are confused with this term and between dependent variable and independent variable, in the next video I'm going to talk more of it. So please don't forget to watch the next video as well. So now here we differentiate u with respect to x, so it will be du over dx. What will here be? We differentiate v with respect to x. What will now be? dv over dx. So let's first of all start with u and x. So we are going to have du over dx to be equal to differentiate 2x. What will be your answer? The answer will be 2. Why? Someone will be asking, why is the derivative of 2x equal to 2? Okay, let me show you something. Anytime I'm looking for the derivative of, let's say, 20x, and I notice that the variable I'm differentiating with respect to is having a power of 1, I will simply take the coefficient in the front as the derivative. If I ask to differentiate 100x, it is 100. But how did that came about? Let me use the instance of 2x, for example. I have 2x, differentiate it. Remember, with our power rule, this x has a power of 1. 2 times 1 is 2. Then we have the x, we remove 1 from the power, that's 1 minus 1. 1 minus 1 is going to give us 0. So we now have 2x raised to the power of 0. But anything raised to the power of 0 is 1. One of the law of indices. So in that case, we have 2 times 1, which is equal to 2. So there's no need going on through this process just to resolve the derivative of 2x. So the derivative of 2x is 2. The derivative of 10x is 10. The derivative of 20x is 20. But under our condition, when it is in respect to x. So if I ask, what is the derivative of 1000x? The answer might not be 1000. The answer will only be 1000 when you are differentiating with respect to x. But if I say, what is the derivative of 1000x with respect to p? You don't have an answer for that. Or I can simply say 0. But I don't know that. How true is that? But we cannot differentiate that. So, if I differentiate 2x now, I have 2. And we have plus here. Differentiate 4. You notice here, remember we are always differentiating u with respect to x. But before has x? No. So because it does not have x, it's called a constant function. It's not carrying any variable. So whenever we differentiate a constant function, we get our answer as 0. So 2 plus 0 is going to give us 2. That means to say the u over the x is equal to 2. Then let's continue from here. We are going to differentiate v with respect to x. We have dv over dx is equal to differentiate x using the same method I showed you. So x is the same as 1x, therefore the derivative will be 1. So we have 1 plus differentiate v with respect to x. Answer will be 0. Therefore, what we have dv over dx is going to be 1 plus 0 is 1. So we have, you can use all these things here to resolve the question. Now, these are formula. That is, we need how many things? We need 4 things. Du over dx, dv over dx. So let's circle them out. We need du over dx. We need dv over dx. We need what x again? We need v, we need u. These are our u. And these are our v. So let's input these 4 things here into this formula. Then we now have dy over dx is going to give us what the first thing here we have v. Look around, what is v? V is x plus 3. So we place it there, x plus 3. That's v. What's the next thing then? The u over the x. Now check out. What's the u over the x? We have 2. So we put our 2 there. It's 2. Next thing we have here is plus. And we have u next. What's u? 2x plus 4. We have 2x plus 4. And we have the v over the x. What is the v over the x? We have it as 1. This is 1. So we are going to have the y over the x equal to, let's open this bracket with 2 times x is going to give us 2x plus 2 times 3 is going to give us 6 plus 1 times 2x is going to give us 2x plus 1 times 4 is going to give us 4. So finally, I think we have some right terms. So we can say the y over the x is going to give us 2x we add up with 2x, we are going to have 4x. And 6 we add up with 4, we are going to have 3. So this is our final answer. 4x plus 10 is our final answer. So you can see clearly, this is how we can use product rule to solve the question. In this video, I've given you the conditions that are necessary for you to use the product rule. Please don't forget about these things. Don't forget to take note of this formula, it must be on your head. In subsequent videos, I'm going to be showing you where to solve product rule without you resolving into the formula. Just go ahead, because you know product rule can solve this question. You can just go ahead and use the formula to solve it, you get it. So that is why you must watch the subsequent videos I'm going to be dropping here. And okay, other than this, if you don't want to go with the product rule, we can also go in that way. What are we going to do? We are going to expand the bracket. Let's expand the bracket. Let's expand the bracket. So we are going to use the algebraic method to expand the bracket here. 2x times x, that will give us 2x squared, plus 2x times 3, that will give us 6x, plus 4 times x, that will give us 4x, plus 4 times 3 is going to give us 12. So now, we can add 6x plus 4x together, that will give us 10x. We have y equals to 2x squared, plus 6x plus 4x is 10x, plus 12. Now, we cannot differentiate y with respect to x. We cannot say the y over the x. So let's start with 2x squared. Using the using the power rule, 2 times 2, what are we going to have? 4. We move 1 from 2. 2 minus 1 is 1. Plus, if we differentiate 10x, I've given you the rule before. Differentiate 100x, you get 100. Differentiate 1000x, you get 1000. So if you differentiate 10x, you are going to have 10. Plus, if you differentiate 12, 12 does not have a variable, it's a constant, so it's 0. So let's not do that. What's our final answer now? Our final answer is 4x plus 10. 4x plus 10, 4x plus 10. Both answers are the same. So please, for more exciting video like this, don't forget to subscribe, to like, and to comment. Thank you.